So today we're going to be solving rational equations. Okay, we're going to do this in 4 steps. The first step, find your domain restrictions, which is something we've just been doing for the last 2 days. Step number 2, we're going to multiply the numerator of our fraction by the missing parts of our least common denominator. Okay, step 3, we're going to solve for the variable. All right, and then step 4, we're going to make sure that our solutions are not part of our domain restrictions. Okay, so this is how this works. We have our problem here. We're going to look at our denominators for our domain restrictions, and we're going to factor this first denominator from our first fraction. We have x squared minus 2x minus 8 if we factor that. Two numbers that multiply to give you negative 8 and add up to give you negative 2 are negative 4 and positive 2. Now you'll notice this denominator and this denominator are the same thing, so like when we did domain restrictions, we don't have to solve for it twice. Once is good enough. So we have x minus 4 equals 0 and x plus 2 equals 0. We solve for x, and x cannot equal positive 4 or negative 2. So when we're done with our problem, we have to make sure that our answers to the equation aren't either 4 or negative 2. Okay? All right, step number 2. Now we're going to look at the equation. Okay? Now when we're doing domain restrictions, we didn't care about the numerator, but when we're solving rational equations, we do care about the numerator. Okay, I'm going to rewrite the problem here. You have 2x plus 4 over, I'm going to write it as the denominator as our factored, minus 4 and x plus 2 equals x plus 1, x minus 4. So what we're doing here is we're going to figure out what is missing in the denominator for each of the fractions compared to the other denominator. Right? And we're going to multiply that missing piece by that fraction. Okay? So if you look at the left side of our equation, we have x minus 4 and x plus 2 in the denominator. Well, out of the denominators that we have, it's not missing anything. It has everything. So we don't have to multiply that side of the fraction by anything. But when we look at the right side of the equal sign, we see that we just have x minus 4 as the denominator. And it is missing the x plus 2 the other denominator has. So that's what we're going to multiply by. Okay, now that we have that missing piece, I'm going to just cancel out the entire denominator altogether. I don't care about it. Okay, and what I'm going to do is I'm just going to solve the numerator. So I have a new equation, 2x plus 4 equals x plus 1 times x plus 2. Okay. Now if I solve this, I have to multiply the x plus 1 times x plus 2 first, which will give me x squared plus 2x plus x plus 2. Now I saw in a number of the tests from the last unit, people multiplied like 1 times 1 or 1 times 2 and got 1 times 1 is not 2. 1 times 1 is 1. So 1 times 2 is 2, not 3. Okay. I'm going to keep combining our like terms on the right side, so I get x squared plus 3x plus 2. And I'm going to subtract 2x and 4 to this other side. Okay, so I will get x squared plus x minus 2 equals 0. Now what I'm going to do is factor that quadratic. The two numbers that multiply to give you negative 2 and add up to give you positive 1 would be positive 2 and negative 1. Okay, so if I solve both those factors for x by setting them equal to 0, I will get x equals negative 2 and positive 1. But here's the last step that's really important. You have to check your solutions. You got to go back up and refer to your domain restrictions. And notice that one of our domain restrictions was negative 2, which is also one of our answers. Well, you can't have that. It's restricted, so you can't use negative 2. So we're going to cross this one out, and our only answer is positive 1. All right, so that's how you do these problems. So let's look at some examples to show you how this works in a couple different ways. All right, number 1, our example. Okay, so again, we have to do the domain restrictions first and multiply by the missing denominators, all right, and then solve. So for the first problem that we're doing, we have x squared minus 2x. I'm going to factor this out to get an x and x minus 2. Okay, so up here I'm going to put down my restrictions. I have x, okay, and I have this x and this x. That's the same thing. I'm going to set that equal to 0, and then I have x minus 2. And I have that twice as well, here and here. Okay, so I solve each one of these. X cannot equal both 0, and it can also not equal positive 2. Okay, so we're going to keep that up there in the upper right-hand corner for now as we solve our equation. Okay, now looking at our equation, we're looking at the denominators. Is the first denominator, which is right here, x times x minus 2, is that missing anything that the other denominators have? Well, the answer is no. Okay, it has an x, which the other one has, and it has an x minus 2. There's nothing that this does not have that the other two denominators have. All right, but now in the second one, 1 over x, that x is missing x minus 2. It doesn't have one of those. Okay, and in the third denominator, it is missing an x. Now, one common thing that students get wrong is they look at x minus 2 as 2 separate pieces. It's one expression. Okay, so yes, it has an x, but it's missing being multiplied by another x. So this is missing an x. So what we have is our equation. If we get rid of our denominators entirely, we have 10 plus 1 times x minus 2, which is x minus 2, equals 3 times x. So here is our equation. Now we have to solve it. Okay, I'm going to rewrite this without the parentheses. So 10 plus x minus 2 equals 3x. Now I'm going to get all the x's on one side and combine the like terms on the other side. I'm going to subtract x. 10 minus 2 is 8, and 3x minus x is 2x. If I divide both sides by 2, I'll get 4. Okay, so now you have to do the check. Is our answer a 4 in the domain restrictions? No, it is not, so it is fine. It works. Okay. Look at number 2. Step 1, do the domain restrictions. Well, our two fractions have separate denominators. There's no factoring necessary. So we have x plus 3 equals 0, and x minus 2 equals 0. So if you solve these, we have x equals negative, or cannot equal rather, negative 3 or positive 2. We're going to leave that up there for now and refer back to it at the end. Next, we have to figure out what is one denominator missing that the other one has. Well, our first denominator of x plus 3 is missing x minus 2. It does not have an x minus 2. As for the other denominator, it's missing the x plus 3. Okay, now that we've gotten that down, we can get rid of the denominators entirely. We have 7 times x minus 2 equals 8 times x plus 3. We distribute. 7x minus 14 equals 8x plus 24. Now we have to combine like terms that we can, so I'm going to subtract 8x and add 14, which gives me negative x, which is equal to 38. Divide by negative 1, and x will equal negative 38. Well, obviously, negative 3 and positive 2 are not negative 38, so this one works just the way it is. Okay. All right. That's number 2. Let's try number 3. This one's a little more tricky, and we'll show you why as we go through it. Again, we're going to factor the first denominator to help us with the domain restrictions. We have x we can take out, which leaves us with x plus 2. Okay. So we actually do have 3 different denominators. We have an x plus 2, and x squared. So let's set them all equal to 0. X equals 0, x plus 2 equals 0, and x squared equals 0. Well, x equals 0, well, it's already done. So we cannot have 0. We cannot have negative 2 because we subtracted 2. And then the square root of 0, if we're getting rid of the square root on the x, we take the square root of both sides. Well, the square root of 0 is just 0 still. So we don't really need it because we already have a 0 there. But it is a separate denominator. That is an important piece. Okay? So if we're looking at this is why this is tricky, looking at the least common denominators and figuring out what's missing. This side has x, but there's just one of them. This side has x squared. Okay, but if you think about what x squared is, it's really just x times x. Well, this side, the left side, already has 1x. It just needs one more. So you're not multiplying by x squared. It just needs 1x to give you x squared. Okay, so we're going to multiply by an x here. It would give you x squared. So we have to multiply by that missing x to the top. On the other side, it has the x that it from that x on the left-hand side, so it doesn't need another one. What it is missing, though, is the x plus 2. Okay? If you think about what we're doing here, if we multiplied, let's do it a different color. We multiplied all of these things together here, and these things together here, you would have, I'm going to move still some space up here, you would have x times x, which is x squared, times x plus 2. Here you'd have x squared times x plus 2. They are now the same, and that's what we're looking to do. Okay? All right. Let's get back to the problem at hand. We're multiplying 3 times x. Oops, that's the wrong thing. There we go. 3 times x. Let's make it blue again, just because I like it. 3 times x. There we go. 3 times the charm equals 6 times x plus 2. Okay, we have to distribute the 6 to the x plus 2, so we have 6x plus 12. I'm going to subtract 6x to the other side, so the 12 can stay where it is, which gives me negative 3x equals 12. If I divide both sides by negative 3, I get negative 4. Now we check my domain restrictions. There is no negative 4 in those answers for the domain restriction, so negative 4 would work as an answer to my equation. Number 4. Okay. Again, step 1, doing the domain restrictions. X plus 3 is already kind of factored. It's already ready to go. X minus 2 is the same, but the x squared plus x minus 6 is not. So we're going to factor that first. Two numbers that multiply to give you negative 6 and add up to give you positive 1 would be positive 3 and negative 2. So we're going to take our denominators, x plus 3 and x minus 2, and set them both equal to 0, and solve for whatever x cannot be, which would be negative 3 and positive 2. All right, now to solve this, we're going to figure out what's missing. Well, our first fraction that has a denominator of x plus 3 is missing an x minus 2. Our second fraction, which has a denominator of x minus 2, is missing x plus 3. And our last denominator has both of those things in it, so it's not missing anything. So I can get rid of my denominators altogether. And at the top, we'll have negative 2 times x minus 2 plus 3 times x plus 3 equals 5. And this is going to be my equation. I distribute the negative 2, gives you negative 2x plus 4. Distributing the 3 gives you positive 3x plus 9 equals 5. By combining the x values, negative 2 plus 3 is going to give you x, just 1x. And I'm going to subtract the 4 and the 9 to the other side. So 5 minus 4 minus 9 gives you negative 8. And that is your answer. Now you check it against your domain restrictions and it doesn't match any of them, so negative 8 works as an answer. Okay, let's try 2 more examples. Then you'll be ready to go for your practice sheet. If we look at our values here, we have three different distinct terms. We have x equals 0, x squared equals 0, and 5x equals 0. So let's solve them all. Well, x equals 0 is done. So you can't equal 0. The square root of 0 is 0, so that one doesn't have to change. If we divide 0 by 5, also doesn't change. You get 0. So this is our only domain restriction out of those three denominators. And that's fine. All right, now let's look at what's missing. So the first x is missing a squared, which means it's missing 1x, because if you multiply x times x, you would get x squared. All right, it's also missing a 5. Okay, the middle equation, or the middle fraction, sorry, has the x squared. It's missing a 5, though. All right, and the last one has 5, but only has 1x, so it's missing 1x to give it x squared. So you can see the least common denominator for this problem would be 5x squared. All right, now we're going to just get rid of our denominators altogether. So we have 5x times 1, which is just 5x, minus 5 times 4, which is 20, equals 3 times x. I'm going to subtract the 5x the other side so that the negative 20 can stay. So negative 20 equals negative 2x. Divide both sides by negative 2, and x will equal positive 10. Since that is not one of the domain restrictions, that works as our answer. All right, one more to go. Trickiest one of them all. So let's look at our denominators. I'm going to factor out an x out of the last denominator, so I get x minus 5. Okay, so I'm looking at my denominators. I actually have 2. I have x minus 5, and I have the x. That's the only two distinct denominators I have for this problem. So I have x equals 0, and x minus 5 equals 0. Solve them both, so x cannot equal 0 or positive 5. Now, looking at my fractions for this problem, there's actually a third fraction here. This is 1 over 1. So when we're looking at what's missing, this first number of 1 doesn't have any denominator even close to resembling the other two, and is missing all of it. It's missing the x and the x minus 5. Okay. The middle denominator, the x minus 5, is missing 1x. And the last denominator, well, it's not missing anything. It already has the x and the x minus 5, so you don't have to do anything with the 2. So if we rewrite this, 1 times x minus 5 is going to give you x squared minus 5x. It's the same thing as the last denominator. Minus, this is an important piece, I'm going to put that 3x minus 9 times x in parentheses. Actually, you know what I'm going to do first? I'm going to put that in front. Let me explain the middle part here. All right, not only are we multiplying this x times the 3x and the 9, this negative sign here causes issues because that's being multiplied by all the terms of that second fraction. Okay, so that's why I put the parentheses here and here around the 3x minus 9 parts. Okay, because you have to multiply that negative sign by all the terms inside of that parentheses. Okay. Same thing would have happened if this was just a regular problem. This negative sign is affecting, oops, I did it again. It is affecting not only the 3x, but it's also affecting the negative 9. Okay, so I had to put that parentheses out in front of it. All right, with that being said, I'll have x squared minus 5x. X times 3x is 3x squared with a negative in front of it is negative 3x squared. That's really ugly, sorry. And x times negative 9 times negative 1, that negative in front again, it's going to give you positive 9x equals 2. So I multiplied both the 3x and the negative 9 by x and by negative 1. So I changed their signs and multiplied it by an x. I can now combine the like terms. X squared minus 3x squared gives you negative 2x squared. Okay. Negative 5 plus 9 gives you positive 4x. And I actually have to bring that 2 on the far side to the other side by subtracting it. to give me 0. Okay. So what I'm going to do here is you can see I have 2, 4, and 2. This has a common factor of 2. But I also have the issue of this negative sign in front. We're not used to factoring quadratics with negative signs in front of them. So we're actually going to factor out a negative 2, which gives me positive x squared minus 2x plus 1. Now what I'm going to do is factor inside the parentheses. So two numbers that multiply to give you positive 1 but add up to give you negative 2 would be negative 1 and negative 1. So my answer is x minus 1 equals 0. X will equal 1. Going back up here to check to make sure that the domain restrictions aren't 1. And they're not, so that's my answer. X equals 1. Okay, so we've shown you a bunch of different examples. Please use this to help you do the practice sheet. This is one of the harder topics of this unit. So it's going to take a bunch of different practice times. I think we're going to do this a lot next week, but I wanted to introduce it today. So it's really important that you try the practice on your own to make sure that you can get it. All right, good.